everyone. In this video, we will be writing polynomial function given one real root and two complex roots. Before we jump into this example right here, let's have a review on roots or zeros of a polynomial function. Zeros or roots of a function are values of x that causes the function to be equal to 0. Now, there are some notations how roots are written in some problems. So in some problems, they write it this way. The roots are 5, -3, 2i, 3 plus minus I. In some problems as well, they write it differently. So they write like x is equal to 5. They also write this as x is equal to -3, x is equal to 2i, and x is equal to 3 plus I. And then this is also the other one since it's plus and minus, so that would also be x is equal to 3 minus I. Now, if we want to change these roots here into its factored form, we are going to use the zero product property backwards. So we can go ahead and rewrite this as x minus 5 in parentheses, which means that if we equal this to 0, then we add 5 from both sides plus 5 from both sides. That's how we got x is equal to 5. So pretty much we switch the sign of this, and that would be in factored form. So in this next root right here, we can go ahead and write this as x plus 3. And this one right here can be written as x minus 2i. And this one right here in factored form, we can write this as x minus 3 plus I. And then that's the other one here is x minus 3 minus I. So this is how we change the roots into its factored form. So pretty much the trick is if we are given the roots in either of these notation, all we need to do is to switch the sign of the root, put it next to the x, and put these two binomial inside the parentheses. Okay, now going back to the example that we have here, we're supposed to write a polynomial function whose roots are 2, -3 plus 5i, and -3 minus 5i. So as you can see here from the title that we have up here, we have one real root. So the real root that we have is 2, and we have two complex roots. So this -3 plus 5i and -3 minus 5i are the two complex roots. Now, please notice that these two are conjugate to each other. Now, please remember the complex conjugate root theorem. This theorem states that if a plus bi is a root of a polynomial, then its complex conjugate a minus vi is also a root of a polynomial. So both of these are roots of a polynomial. So in some cases, if we are given only this complex root right here, automatic, its conjugate is also a root. So automatic, we have to write that -3 minus 5i. Okay, so these roots that we have here can also be written as x is equal to 2. That's x is equal to 2. This one right here can also be written as x is equal to -3 plus 5i. And this other root right here can also be written as x is equal to -3 minus 5i. So we can rewrite that. Now, we are going to use the zero product property to determine the factors. So when we say zero product property, backwards, we're supposed to determine what is this in factored form. So then this would come out x minus 2. So that if we have x minus 2 is equal to 0, that comes out x is equal to 2. So we're doing the distributive backwards. Or the other trick to this is we just have to switch the sign of this one. So that would be, since it's a positive 2, we write x minus 2. This one right here can be written as, again, we switch this and keep. So that would be x plus 3 plus 5i. So what I did was I switched this, it becomes a plus 3, and then I keep the 5i. And we do the same thing for the other one. That would be x plus 3, I switch, and then I keep. So that's minus 5i. So then these are their, so this is the factored form of the polynomial that we're trying to figure out. So what are we going to do next is we are going to multiply all these three expressions here. So we're going to multiply these two first. In order that we can do that, we're going to use a 3 by 3 box because that's 1, 2, 3, 1, 2, 3. So I will have a 3 by 3 box here multiplying these two. So we're going to use the area model. Okay, the one that we write on the box here would be these terms right here. So it's going to be x, 3, and 5i. So I wrote the x, 3, 5i. Then I will write this on the vertical side right here. Okay, the next thing we're going to do is to multiply this. So this becomes x squared. And then x times 3 is 3x. X times negative 5i is negative 5xi. This is 3x. And then 3 times 3 is 9. 3 times negative 5i is negative 15i. And then 5i times x is 5xi. 5i times 3 is positive 15i. And then 5i times negative 5i is negative 25i squared. So then we go ahead and remember that these two are canceled out because we have a negative 5xi plus 5xi is a 0. Then these two are also crossed out because we have negative 15i plus 15i is a 0. So we can cross this out so that we can go ahead and simplify this as we start right here. So that would be x squared. And then these are like terms. So I can combine these two. That would be a plus 6x and then plus 9 minus 25i squared. Now we remember that I squared is equal to negative 1. So then I can go ahead and rewrite this as so the product of these two polynomials that we have here is x squared plus 6x plus 34. So I can go ahead and rewrite this as x minus 2. That's the one that I got on the first root right here. And then I combine these two together. It came out to be x squared plus 6x plus 34. The next thing that we're going to do is to multiply these two here. So then we go ahead and write a 1, 2, 3 by 2 box. So I'm going to show the box right here. It's going to be a 3 by 2. Okay, so I've set up the box for this factors right here. So I have written in here that's x squared, 6x, 34, and then x minus 2. So then I'm going to multiply these two. So this would come out. Okay, since these two are like terms, so I can combine these two together and combine these two together. So this would come out. Okay, so this would come out. That's gonna be x cubed. So that's x cubed plus, this is gonna be negative 2x squared plus 6x squared is a positive 4x squared. And then we have a negative 12x plus 34x is 22x. And then we have a minus 68. So then this function would be f of x is actually equal to x cubed plus 4x squared plus 22x minus 68. And this is the polynomial that has these roots up here. So that which means that this polynomial right here will have a root of 2, negative 3 plus 5i, and negative 3 minus 5i. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!